Welcome, everybody. I'm Luchan Fogoros, and today our guest is Evan Kaplan, the CEO of InfluxData. Welcome, Eric.
Thanks, Luchan. Great to be here. Great to have a conversation with you.
Yeah, so let's talk a little bit about your company is basically built a time series database. Maybe as we hear a lot of the importance of this machine data, the analytics, the storage, can you maybe set a stage a little bit to give us where does the time series database fit into, and particularly perhaps in the manufacturing context, and what are some of the advantages that it offers over some of the traditional databases?
Yeah, sure. So, Luchan, you have a strong background in IoT and manufacturing IoT, so we can be a little bit of shorthand together. Maybe start with a little bit of the origin story is the company was founded by Paul Dix, who's my partner in this, and Paul was a developer who had built a bunch of time series databases on top of existing sort of relational databases for Wall Street primarily.
Mm-hmm.
And that area is known as tick data, which is you're really looking at trading, high frequency trading, all sorts of stuff to counter multiple trades and all the factors associated with trades. So it did not actually start in the manufacturing space. But he open sourced the code for it, and it became immediately popular and really started to grow about 2015. Today, there are roughly 1 million users who run it daily that we can see. So we can't exactly see what they're doing. A lot of those people are hobbyists, but a lot of them are large industrials and other sorts of companies. And so Paul's thesis was that over time, the amount of data coming from sensors analytics, broadly described, not just in manufacturing, was going to increase pretty dramatically. My background was in networking and security, and so IoT was, of course, a natural understanding as the cellular networks got built out and the distributed networking infrastructure got built out in the cloud computing, that you could see the fit around this IoT stuff. And so the project became immediately popular. And what we saw with those first 1,000 or 2,000 users is a lot of people were using it in the broad IoT space and then starting to use it in the manufacturing space. And so why use this? Why use something like Influx?
Mm-hmm.
But it turns out the data problem is actually pretty significant when you start thinking about the massive scales associated with broad-based sensor networks, whether they be in discrete manufacturing or whether they be in anything from satellite communication to network telemetry to all those sorts of things. Is you have to ingest data incredibly fast at high volume at high concurrency. Two is you have to be able to query that data immediately. If you're going to build anything that looks like a control system, the ability to query that data immediately is really, really important. Three is you need to be able to summarize the data or downsample the data in a meaningful way, because you don't really need to keep high resolution data around really long periods of time. And what that means is you're evicting data quite often and quite frequently, which most databases aren't designed to evict data. So if you take a really good broad-based time series, and there are others besides us, real-time kind of platform, really, really interested in measurements and things like that, you have to be able to ingest, you have to be able to query incredibly fast, you have to be able to evict data, and you have to be able to summarize data fast. You also have to deal with high cardinality. And particularly as we get into the world of AI, as you get more and more descriptors on your data, on your measurements and things like that, you're really dealing with high cardinality data, and that chokes most normal databases off. Really changes the query performance, it even changes ingest. And so you try to design a platform that's capable of doing all of that. When we first started, we did it pretty well, but now we do it really, really well. But it's taken a time, it's been a journey. Databases are not for the lighthearted. They're not, anyway.
Thank you for the insights there. So just to summarize, the ingestion high volume of data and rapidly and continuously providing real-time insights is what where you play into this
Yeah.
industrial IoT, whether it's manufacturing or financial or energy out of the markets, but those are the area that it's at. So maybe double click a little bit on some of the examples. You touched a little bit on how it's AI, but some of the examples where the time series database can power the real-time analytics in IoT or industrial IoT.
Yeah, some good examples. I think you already know that PTC is a large OEM, as is Honeywell, as is Schneider. Siemens is a large customer. It's Rockwell. So lots of these companies have come out of the traditional historian world, which was recording primarily for observability, in which the real-time nature of it was not as critical. But the monitoring stuff is super valuable, so it's not dismissive at all. It's a super important piece of it. A good example of where you start seeing the value of this kind of stuff is, it's personal because I have these at my house. I have these Tesla Powerwalls, and so the Powerwalls are outfitted and report back to with Telegraph and report back to an Influx database instance. And the Powerwalls actually can pump energy to the grid and actually trade energy with the grid with things like virtual power plant. And there's not just Tesla, but other manufacturers in the alternative energy. And there's a time base of that. Like you have a few seconds by which you can make that trade and do that dynamic. And so you need to be able to see that kind of stuff in real time. So I think that's a good grounded because a lot of people can really understand that. In the manufacturing world, if a process control is falling out of band, given the value of a discrete manufacturing or even a process manufacturing line, process controls that fall out of band are immediate problems. Like they're not,
Right.
And so at least being able to see those. Now, whether you're alerting a human being or you're issuing a command to self-correct, which we're capable of doing in both, that's a decision based on how your operations work. But the point being is it has to be available. The data has to be available right away. It has to be queryable right away, and the queries have to be performant.
Got it. Now you talk to a lot of companies. You referenced some of the large ones that we happen to also serve. But what are some of the factors that's driving the acceleration of this time series database market that you see out there?
Yeah, it's a great, and it goes broader than manufacturing, and so it handles, really, if you think about the world that we're living in, we're seeing an increasing sensorification, if you can make up a word, of the world, which is sensors are getting incredibly cheap. They're in everywhere. They're in your watch, you're in your healthcare, you're in your cars, you're in your smart cities, you're on your manufacturing lines, you're in your buildings. The ability to monitor things has changed so dramatically in just the last 3 to 5 years. And so as you think about how to handle, in some cases, more than 1 billion writes per second, right? And the queries that match up to those sorts of things, you now move from a world that was highly generalized, in which the database was an afterthought. So if you had built something, even in the manufacturing floor 20 years ago, you probably built it on Oracle or on OSIsoft or on Wonderware or traditional platforms. But as that intensity of data goes up, you're moved from these general purpose kinds of databases or even these industry specific ones changes. And now you're looking for something that can be part of a modern data stack, something that's engineered continuously to be higher and higher performance, right? Because all of a sudden that performance of that core foundational piece is what turns out to be the limiting factor. Because now you can collect the data everywhere. You've got a network that can supply it. And so now the limiting factor comes, how quickly can you process that for information? Does that feel like you answered your question, Luchan?
Yeah, yes, it did. And thank you for that term, sensification. I could also see another term coming up soon, influxification.
From your, as my mother would say, from your mouth to God's ears. But I'll settle for sensification. What
are some of the developments that you foresee in the future of the time series. You've mentioned the amount of data, the huge amount that needs to be processed fast, but what are some of the other things that you see out there? So, and is data quality be an issue? I mean, coming from financial market, you have to be very specific and in process. Yes, there are historians out there who could save the data and you can make it available, but what about the quality of the data or some of those?
I think, well, first of all, it's a great question. So again, it comes back to this notion of where does the modern data stack go? And then how does that apply to your world of manufacturing and industrial concerns? So I think what we're seeing with the modern data stack, and it's always been kind of the kind of a grail, which is how do you get the data out of silos to make the best use of it, right? Mm-hmm. And so there's some interesting things going on. And I don't know how well you follow this, but the movement towards these lakehouse architectures from what previously would have been called a data warehouse, but increasingly a lakehouse, and the lake being describing some vast amount of data that's put into a general store that can be queried generally with SQL, that can be queried to really create operational insights, not just business intelligence. And so a lot of times that the operational data has been segmented in these historian-like platforms, right? Without being able to turn them into marry them with the broader business insights that are required to make some really strategic decisions. And so we're seeing much more at the early stage of this lakehouse, lakehouse architectures. The problem with the lakehouse architectures is that they're not built for real time. They're generally batch oriented, and so you can get insight and things like that. And so what I see over the next 3 or 4 years is the marrying of these lakehouse architectures with front ends like Influx and other real-time analytics things that are capable of collecting, storing, but can be addressed within the broader lakehouse. So a query can be generated from a Snowflake or a Databricks that can query the data that's sitting in Influx as if it's native. And the way we've built our platform, this 3.0 platform, is we built it to take advantage of that lakehouse pattern. And I think it's a really important pattern, this movement towards a modern data stack as opposed to these customized solutions. So with that, if I think goes a really important thing in the world that you and I live in, particularly, and you're the expert in, is I think what's going to happen on the, let's call it the factory floor, just for a metaphorical, what's going to happen on the factory floor is you're going to move what they've traditionally called it is moving from OT to IT. Mm-hmm. But I don't even think of it that way. I think of it as moving from OT to developers, right? Moving to lots of these open source based projects where people can assemble really strong solutions and build sort of, let's call them industrial stacks, if you will, data stacks of, everything from MQ collectors to time series databases to predictive analytics capability. And so that developer-led revolution is one I see taking over the next 10 years, which is, so IT is not a good, I don't think that's a good metaphor for where this goes. I know that's what a lot of people talk about, but I think it goes directly from OT to developer.
Yeah, I like that. And actually I had in mind to pose another question. So in a context of even the reference that you made, an MQ collector or some of the protocols as you move from OT into developer worlds, where do you see some of the protocols that allows that movement of the data from the plant floor to the developer world? Whereas you see more of the MQTT direction, you see more of the traditional OPC UA. Where do you stay on that debate?
So one of the problems with being a foundational component is a lot of times, I don't want to pretend to really understand the stuff way above me in the stack, mm-hmm. if you will. We view the database and the architecture fundamentally foundational. And so we're not coming from a historian or broader background. What I would say is it's not hard for us to support. We do OPC UA, Modbus, MQTT. Whatever the machines are talking is not the problem.
Mhm.
And so I don't know where that part of the industry goes, whether they standardize on kind of an open MQTT or something like that, or whether they actually use the straight developer stuff like Kafka and some of those other broader tools. You'd be more the expert on that. All I know is, in my narrow world, is that a highly performing database has to sit underneath all of that to make it work great.
Makes sense. And I think I'm going to switch something into the conversation to an area that I think hopefully it's empowers some of the listeners out there. And if you are in the audience, feel free to leverage the hashtag on a screen to ask more questions, and we bring more subject matter experts from Influx and others in the near future. But I guess, what advice do you have for business professionals that are navigating this intersection of industrial data or industrial IoT, data management, and digital transformation? How could they best position to extract value from a time series database and emerging technology?
It's consistent with you can't divorce yourself from the large scale dynamics in the broader data world. And what I'd say the large scale dynamics are, one is the open source foundations that are being built all over the place. Two is the movement to cloud in some shape or another.
Mm-hmm.
Three is the embrace of AI. I'm always sensitive because it sounds like, it's the latest, greatest, but the embrace of predictive analytics, the embrace of predictive maintenance, the use of the tools that are available either in open source or in the cloud from these vendors to assemble, to build solutions. And so my advice, and you should take it with a grain of salt because, I'm a CEO of a company that's part of this, but is that it behooves the companies to build and hire that developer architecture expertise to design these next generation of systems. And I don't just mean the companies, the industrial companies that run it. I also mean the large scale suppliers that supply that software today, whether it's Schneider or Honeywell or PTC. And I see that start to happen, and I expect it'll accelerate. Increasingly, they're becoming experts in the modern data stack, and I suspect so will their customers over time. That to me is the broad transition going on here. Slow, but broad, because industrial stuff doesn't move quickly.
Thank you, Evan. Appreciate the insights, and look forward to updates from the reInvent and others in the future from InfluxData.
Thanks, Luchan. It's great to talk to you, and it's great to have somebody who knows so much about this space. I really appreciate it.